So let's crack on, eh? Okay, because of the angle that I have the compound swung out at, we have to cut this taper from the rear. So the only tool I can get around to reach is a boring bar, but we should be alright. So if we run it at a slow speed, so we don't get any vibration, and I think we're going to have to use a bit of coolant on it to help. I've just noticed there I'm getting something's moved. That ain't running true. Let's just readjust that. As happens from time to time. Yeah, something's moved there. Still feels alright in the jaws. Shit, too far. That's got him. Okay. Where were we? Okay, well that was a pain in the ass because the piece moved again. I'll show you, might be able to show you a better picture what happened later on. It's really because of the undercut we'd put in the rear where we were gripping for the grinding allowance, and the notches in the jaws there sort of weren't lining up real well. So we've gripped him on the outside now, so tapped him in true. So we'll keep on trucking. Would have been a good one to have for bloopers, especially if the part fell out. Okay. Yeah. increase our speed a bit. I think we're pretty close. Now to check to see how we're going. This is where, remember a few episodes ago we made our R8 taper gauges. This is precisely what this is for. I'll get a measurement. So we're just under 3 inches. I think we need to be 3 inches. On the, I've already turned this one, so this is going to be our guide for all of them. Just a fraction under 3 inches. And same here, no, we're there. So that's our taper complete. So that's one of the uses for the R8 gauge. It'll serve like we've just used it now for the roughing for a guideline. And when we do our final finish grinding, we use the other end of the gauge because that is exactly the larger diameter of the taper. And what we do is we reference the front of the gauge to the rear of the part, and that will give us our length as per the drawings. Okay, so what we'll do now is we'll just tackle this radius, we'll get this all cleaned up and then polished up, and then this one will be done. So this is our radius tool. So every time I use this on this job, I just give the radius a touch up on the oil stone. Just keeps it nice and sharp and you get a nice clean radius. We'll get this set up. And on centre, we just use our vernier height gauge, which I always keep preset. Okay. And we will use the centre just to support it. And a slower speed. Okay, that's come up alright. So I'll probably switch over to a carbide tool now and just take that the hardened edge off there, because this high speed steel struggles with this hard stuff. So. Okay. Just see if I can just break that edge a little bit. Okay, gives us a nice rounded edge on there, nice radius in there. So I'll just give this a polish up and this one's done. We have to bore out one of the lathe drive dogs, as it just doesn't quite fit the arbor we need to use it on. So we'll just take a little cut through. Okay, this is our setup for machining the tapered portion as well as the parallel portion. We're up to the tapers now, so I'll also start doing it between centres, as they'll all be ground between centres when we finish. We'll be coming up to a finishing cut now. So that's close. So to check our size for these, we'll take it back out the lathe. We won't need the drive dog on anymore. That comes off. Now, we use our taper ring gauge. We set our taper ring gauge over. We're looking for 3 inches. So we've got about a 1/16 to go. So we just keep checking it with our gauge. So what we do now, we don't need the drive dog on anymore. We can just use the friction between the centres is enough to drive it. Wipe it with our hands, make sure it's clean. And we're there, bang on. Okay, so that's good enough for a measurement for our roughing procedure, because these are still oversized tapers. So, and they will get ground as we've explained. So I'll run through the rest of them like that, and then I'll put them back in, change the tool, and we'll just face off the back, and we'll put a small radius on here, and of course there's a chamfer to do on here. Okay, we're just on our last of the Arbors doing the R8 features. We had a situation come up with this particular one here. This is a slitting saw arbor that we're building. Now what's happened, this is all too common in machining. We've roughed it out, and this one has a hole running all the way through the guts of it, so she's hollow. So when I set this back up in the chuck, I just gripped and clocked it in the forejaw here. I had about 6th or 7th hour run out down this end here. So we had this end running true, and 6th or 7th hour run out here. It wouldn't tap straight, it wouldn't do nothing. So what I think's happened there, because we've taken so much off the outside, and we also have a hole drilled through it, I'm pretty sure it's the stresses in the steel that have caused this one to warp. Now, when I did the other one, this one here also has a hole through it too, but it has a smaller bore in the end, so we were able to complete this one between centres, so it didn't have the same effect show up. So what we're going to do to counteract this one, I've machined up a little slug with the centre and the end of it, because the bore on this is too big for my centre. My centre just disappears inside. Now I was thinking about using an extended centre, and that's why I did cut an angle inside to take a centre, but what I'm going to do is I'll press the slug in there, and we'll pick up on this centre here. When we go to do our finished grinding, we'll do the same procedure with this one. So we'll may do the same procedure with the ER as well. I'm not sure yet, but we'll wait and see. So we'll get this slug pressed in and set this back up in the lathe and see how it's looking. So hopefully we should be able to save it. Well, okay, putting the slug in the end seems to improve things to something we can work with now. So up at this end here, we got a thou run out, which is quite acceptable. So if we come to the middle of the shaft, getting up towards 2 thou there. So we'll come, see how we're travelling here. Re-zero. So we've got 3 thou in this area here, come up to the end. See, that reduces that, so what have we got? 2 thou, thou and a half. Yeah, thou and a half down the very end. So that's well under the limits that we've allowed for grinding. Bear in mind too, I do expect these to possibly move or warp a little bit, possibly during the quench when we heat treat them. And this just goes to show that it does pay to rough out your entire job first and then go back and finish off your journals, because this stuff does move. Most steel, moves once you start taking off the outer layers, and especially if you go and then put a hole up the middle of it. So never finish any one journal before you've got all of the others roughed out. So anyway, we'll get this last tapered feature done and then back onto the opposite end features. So now we're just running them all through again, the ones we haven't done. We're just doing the finishing operations on the rear of the R8 feature. So all this is done now, all our tapers are done. So we just leave a small radius down the bottom there, just face it across, and then we'll put a radius on the corner there. Get rid of the bird's nest. Okay. Yeah, let's give that one more, I think. Now that's good. Okay, we'll swap our tool over. So we have a little corner rounding tool here. And we better unlock our carriage, otherwise we're going nowhere. So we just eyeball this tool into position so the front, or so the corners of the tool don't contact the face or the OD. We'll just sort of split the difference a bit. Okay, that looks good there. Make sure we're clear of everything. Always give it a spin with when you're using lathe dogs and you've got other bits protruding out for counterweights and such. So protruding out for counterweights to offset the weight of the dog. So we'll just run that a bit slower. Okay, let's just give that a touch more. I think that'll get it. Okay. So, on with the next one. Okay, on our face mill arbors here, what we've got to do now, we just have to cut this relief in the front face relief, and also the grinding relief just in the corner here. And then we'll have this tapped hole to do on both of them. So. Okay, so we bring our tool into about there. Okay, we've just got to change the angle of the tool now so we can get the grinding relief in. We'll just bring him round to a bit better angle. Something like that. That looks pretty good. So we've got to just break these edges. So we'll use our new tool for that, the DCBN, which is this one here. So we get to use the edges we don't normally use on the CNMG insert. This is a DCBN R. R is for right hand tool so it turns in the left hand direction. I'm just eyeballing a 45 degree here. Chamfer there, and one on the end here. No burrs, feels really good. Okay, so as we just mentioned before, it's just the hole to drill and tap in the end of the arbor for the mounting bolt to hold the cutter on. So we can see now the reason why I chose to do all those operations between centres, because there's so many small operations, little individual operations to do that are quite similar or the same on them all, especially the R8 end. It was just quicker and easier to just keep popping them in and out the lathe between centres rather than mucking around with a lot of tool changes. So we've gone as far as we can with our work between centres with them now. So what we're going to do now, we've got holes to drill, so we've got to drill out the guts of the ER collet holder, drill and tap the holes in the ends of the two face mill holders. This one here we have to screw cut the end of it. That's finished, and this one here is just the holes we haven't drilled yet on the end to mount to the boring head. So it doesn't matter which one we tackle first, whether the ER or these two. I probably might get these two out of the way since it's a relatively simple job, and then that leaves in the next video we screw cut the thread on the end here. We have to bore out the features on the ER, and we also have to screw cut the 50mm thread on the OD of it. So I think we'll wrap this one up, and okay, as we were saying, the two arbors that I have to drill and tap the holes in the end, I'll do that off camera because you've already seen holes drilled and tapped when we've done the other end there. The tricky one, well, there's a left hand thread to do on the stub arbor. That shouldn't be too bad. The tricky one, however, is going to be the thread. It's a 50mm external thread that we have to do on the ER40 collet holder. I'm pretty sure it's 50, I'll still have to confirm that. Now the reason why that's going to be, we've got to think the way we're going to tackle that. These get heat treated. So you have your tapered bore inside. So when they're quenched, it's quite probable you're going to get a different expansion or a different shrinkage rate from that end to further down to here. It may come in like a carrot shape because of the thickness difference, the wall thickness changes. Now when I look at the way they've made this one, it appears to me, I don't know if the camera won't see it, okay, you've got a black line there at the end of the thread and it stops just there. That black line comes around and stops. Well, that's the end of where the thread's been recut after heat treatment. So I'm guessing they've cut this thread to probably 90% of its depth, 80% of its depth, heat treated it, and then they've gone in with a die, it'll be on a production run, and recut the thread to its final dimension. That way they don't have to cut so much hardened material if they pre-cut the thread before heat treatment. So I'm thinking about we'll probably go along the same lines. So we'll single point the thread down to 80% of its depth, heat treat it, and then we'll single point it to final depth after it's been tempered. Now, so things don't go pear-shaped while we're doing that, I'm going to actually get another piece of material. I've got a spare piece which is the same material that we have our one made out of, and I'm going to do a dummy run with a thread. I'm going to heat treat it and see how much it, just to see how it reacts, and also if I can still single point the other 20% of the thread after heat treatment. Because I don't want to stuff this up. There's too much work's gone into this to risk buggering it up. So worst comes to worst, if it turns out that I can't screw cut it under, well, after it's been heat treated, what I'll do, because all of the thread and the tapered section of the ER, we're still well into the 50-55 Rockwell area of this piece, so we're still nice and hard there, well above the hardness of a Chinese one. What I may do is heat treat just the top, or just the first 2/3. Say we get up to about that area there. So from there down we heat treat and hope that we don't soften that. That's another option I can consider, but we'll all try the dummy piece first and see how we go with that. So that will all be in the next episode, so should be quite interesting. Anyway, take care, be careful on your machines, and take it easy.